Optimizing and controlling process use statistical process control. SPC tools and procedures can help you monitor process behavior, discover issues in internal system, and find solutions for production issues. Statistical process control is often used interchangeable with statistical quality control. Control chart helps one record data and lets you see when an unusual event, such a very high or low observation compared with typical process performance occurs. Control chart a chart attempts to distinguish between two types of process variation. Number one is common cause variation, which is intrinsic to the process and will always be present. Number two is special cause variation, which stem from external sources and indicates that the process is out of statistical control. Various tests can help determine when an out-of-control event has occurred. However, as more tests are employed, the probability of a false alarm also increases. Statistical process control (SPC) is the application of the same 14 tools control process inputs in independent variable, although both terms are often used interchangeable. SQC includes acceptance sampling where SPC does not. An effect diagram. For example, under the heading Machines, the idea materials of construction shows four kinds of equipment and the several specific machine numbers. Note that some ideas appear in two different places. Calibration shows up under methods as a factor in the analytical procedure and also under measurement as a cause of lab error. Iron tools can be considered a method problem when taking samples or a manpower problem with maintenance personnel. The figure below shows a check sheet used to collect data on telephone interruption. The tick marks were added as data was collected over several weeks. Start using the check sheet template to track up to 10 defects on each day of the week. This tool also creates a histogram bar chart and Pareto chart using the check sheet data. The control chart is graph used to study how a process changes over time. Data are plotted in the time order. A control chart always has a center line for the average and upper line for the upper control limit and the lower line for the lower control limit. These lines are determined from historical data. By comparing current data to this line, you can draw conclusion about whether the process variation. Histogram. It is similar to a bar chart but a histogram group number into range. The height of each bar shows how many fall into each range and you decide what range to use. Figure 1 shows how many customer complaints were received in each of 5 categories. Figure 2 takes the largest categories. Documents from Figure 1 breaks it down into 6 categories of documents related complaints and show cumulative values. It all complaints cause equal distress to the customer working on eliminating document-related complaints will have the most impact, and of those working on quality certificate should be most fruitful. Scatter diagram. There are 24 data points. Median lines are drawn so that 12 points fall on each side for both percent purity and ppm iron. Scatter diagram to test for a relationship. They calculate. Example is A is equal point in upper left plus point in lower right. B is point in upper right plus points in lower left. Q, the smaller of A and B, equal the smaller. N is equal A plus B. Then, they look up the limit for N on the trends test table. For N is equal the limit. Q is equal to the limit. Therefore, the pattern could have occurred from random chance and no relationship is demonstrated. Stratification. Now, patterns can be seen. The data from reactor 2 and reactor 3 are circled. Even without doing any calculation, it is clear that for those two reactors, purity decrease in ion increase. However, the data from reactor 1, the solid dots that are not circled, do not show that relationship. Something is different about reactor 1. The 7 supplemental. In addition to the basic 7 QC tools, there are also some additional statistical quality tools known as supplement. 1 is data stratification, 2 is defect maps, 3 is event logs, 4 is process flow chart, 5 is progress center, 6 is randomization, 7 is sample size of determination. Three basic of statistical process control is center line, lower control limit, and upper control limit.
The control chart is a graph used to study how a process changes over time. Data are plotted in time order. A control chart always has a center line for the average, an upper line for the upper control limit, and a lower line for the lower control limit. These lines are determined from historical data by comparing current data to these lines. You can draw conclusion about whether the process variation is consistent or is unpredictable. Control charts for variable data are used in pairs. The top chart monitors the average or the centering of the distribution of data from the process. The bottom chart monitors the range or the width of the distribution. If your data were shots in the target practice, the average is where the shots are clustering, and the range is how tightly they are clustered. Control charts for attribute data are used in singly. Control charts have 4 key pictures: 1. Data points, 2. The average or center line, 3. The upper control limit, 4. The lower control limit. Control chart show the variation in a measurement during the time period that the process is observed. Monitor processes to show how the process is performing and how the process are affected by changes to the process. This information is then used to make quality improvements, help to identify special or assignable causes for factors that impede effective performance. When to use a control chart? When controlling ongoing processes by finding and correcting problems as they occur. When predicting the expected range of outcomes from a process. When determining whether a process is stable. When analyzing patterns of process variation from special causes or common causes. When determining whether your quality improvement product should aim to prevent specific problems or to make fundamental changes to the process. Basic procedure. 1. Choose the appropriate control chart for your data. 2. Determine the appropriate time period for collecting and plotting data. 3. Collect data, construct your chart, and analyze the data. 4. Look for out-of-control signal on the control chart. When one is identified, mark it on the chart and investigate the cause. Document how you investigate what you learned, the cause, and how it was corrected. Out-of-control signals, a single point outside the control limits. In Figure 1.16 is above the UCL or upper control limit. 2 out of 3 successive points are on the same side on the center line and farther than 2 from it. In Figure 1.4 sends the signal. 4 out of 5 successive points are on the same side of the center line and farther than 1 from it. In Figure 1.11 sends the signal. A run of 8 in a row are on the same side of the center line, or 10 out of 11, 12 out of 14, or 16 out of 20. In Figure 1.21 is 8 in a row above the center line. Obvious consistent or persistent patterns that suggest something unusual about your data and your process. 5. Continue to plot data as they are generated. As each new data point is plotted, check for new out of control signal. 6. When you start a new control chart, the process may be out of control. If so, the control limits calculated from the first 20 points are conditional limits. When you have at least 20 sequential points from a period when the process is operating in the control, recalculate control limits.
Good day, my name is Labi Bergonias, and I'm here to discuss the implementation and deployment of statistical process control. The implementation and deployment of statistical process control have three phases, which are the preparation phase, the planning phase, and the execution phase. Let's start with the preparation phase. Step 1, commit to SPC. Kinakailangan po na dedicated tayo sa gusto nating business dahil sa isang business po kinakailangan ng paggastos ng pera, paggamit ng human resources, pagbabago ng organization culture, at pagkuha ng mga empleyado na may mga bagong kasanayan para po mapagtibay yung business na itatayo natin. So, we really need to commit to our business because we are setting ourselves on a path to learn and grow as an individual and as an owner of a business. Step 2, form an SPC committee, which is responsibility po ng top management kung saan siya po yung mag-guide para po mapamiliarize yung mga employees sa mga dapat nilang gawin. Kasi po, the primary function of committee is to contribute to the efficient operation of an organization. In most cases, a committee is concerned with the communication of information and with assisting the leadership in the decision-making process by providing needed information. So, yung typical team po ay naglalaman ng representative from manufacturing, quality assurance, engineering, finance, and statistics. Kaya po sa isang manufacturing plant, kinakailangan po ng manufacturing member na magsisilbing team leader kung saan sila po yung magpaplano at mag-organize ng mga implementation para po sila po yung mag-offer ng opportunity para sa mga problem solving at mangalap ng mga multiple point of views na makakatulong para sa execution phase. Step 3. Train the SPC committee. Providing training and development to employees allow employers to pinpoint the knowledge and skills they want their employee to have. Training and development program can educate employees about new skills or provide updates on existing skills to enhance productivity. So, kinakailangan po na mabigyan ng basic training yung mga workers bago sila magtrabaho. Kasi po, kadalasan po yung mga workers or yung bagong tauhan po ay kokonti or madalas wala pa po silang alam about sa process. Kaya po, kinakailangan nila ng training mula sa mga expert para po, pag natapos na po nila yon, hindi man po sila maging expert, pero magkakaroon po sila ng sapat na kaalaman. Next po is planning phase. Step 4, set SPC objectives. Objectives direct company's activity towards achieving the goals and vision of the owners and help with decision-making that allows businesses to provide what their main focus should be. Sa madaling salita po, ito po yung pag-set ng goals or pag-set ng mga layunin para sa program na gagawin. Dito po pumapasok yung tanong na ano yung naasahan natin mag-gain sa SPC or kung paano natin ma-measure yung success from customer feedback, reduction in scrap, at lower cost of quality na kinakailangan po nating ma-review from time to time para malaman natin if valid at meaningful pa po ba yung ginagawa natin para sa isang product. Step 5. Identify target processes. The target business processes are defined consistently with the business function model and the organization business reference model. Processes are a group of related business activities performed to produce an end product or provide service or service component. So, sa pamamagitan po ng paggamit ng SPC, imposible po tayong mag-attempt ng iba't ibang processes at once. Kaya po, kinakailangan pa po siya ng several weeks na pag-aaral about sa designing ng SPC application, collecting data and interpreting their meaning, getting the processes under control, and plotting and evaluating control chart data. Sa gayon po, kinakailangan po nilang pumili ng best process para sa initial implementation na alam nilang papatok agad sa mga customers. So, pag alam na po nilang magsa-success or papatok yung product, magkakaroon po sila ng confident na ipagpatuloy yung process na mahalaga. Step 6, train appropriate operators and teams. Sila po yung mga taong involved sa mga collections, plotting, and interpretation ng SPC data. So, kinakailangan po natin na ma-implement na magkaroon ng training yung mga operators at teams for 1 or 2 day session. Kasi po, pag nagamay na po nila or alam na nila yung mga dapat nilang gawin, pwede na po silang mag-expand beyond initial projects, which allows team member to feel valuable to their company, and it allows everyone to be clear on what to do and how to do it. The more people you have on your team that are well trained, the more you will stabilize your turnover rate and build the best possible company that we can. Step 7. Ensure repeatability and reproducibility of gauge and methods. Kinakailangan din po sa planning is yung lahat ng measuring instrument from calipers, micrometers, at measuring machine is calibrated at certified sa repeatability at reproducibility performance or magagamit at mapakikinabangan pa ulit natin after making one product. Kasi po halimbawa po sa machine na ginamit natin for making one product, kinakailangan po na ma-ensure natin na pwede po ulit natin gamitin pag gagawa na tayo ng panibagong product para po hindi sayang yung pera na ipupundar natin para sa machine na yun. Step 8. Delegate responsibility for operators to play a key role. As a last step po sa planning phase bago magsimula ang SPC execution, kinakailangan po na italaga ng management yung mga responsibilidad ng mga process operators para po sa pagpapanatili ng control chart ng SPC, from collecting at plotting ng data, at tamang action po na dapat nilang gawin once na magkaproblema. Tapos kinakailangan po na ipaalam natin sa mga operators na para sa kanila itong mga function na to, which is kinakailangan alam din ng lahat. So ayan po. Next po is execution phase, which start at step 9, flowchart the process. Ito po yung unang step ng SPC execution phase. Dito po natin malalaman yung process ng flowcharting at characterizing ng process na pwede nating i-apply sa SPC. Dito po natin makikita yung mga inputs, outputs, at steps para maintindihan ng lahat. Step 10. Eliminate the special causes of variation. Yung special causes of variation po is about sa process na hindi pa na-encounter before na nagdudulot po ng unpredictable factors. So ngayon po na alam na ng mga workers yung process, time na po para i-identify at eliminate yung mga special causes of variation. Dito po pumapasok yung mga cause and effect diagram, kung saan nililista po yung mga factors na posibleng maging impact at effect habang ginagawa yung output. Yung pag-eliminate po ng special causes ay ginagamitan ng team effort kung saan kasali po yung mga process operators, initial process suppliers, at customers. Dito din po kasama yung mga engineerings at quality assurance personnel. Step 11. Develop control chart. Dito po pumapasok yung mga statistic expert or consultant na nakakatulong para ma-develop yung mga appropriate control chart at makalculate po yung mga valid upper, lower control limit at progress average. So, yung pagpili po ng angkop na control chart type, yung pag-determine kung anong klaseng data po yung gagamitin. Step 12. Collect and plot SPC data. So, ayan nga po, sinabi po sa step 10 na kailangan po ma-eliminate dun sa mga special causes na pwede ma-encounter habang nasa process. Pero dito po sa step 12, kinakailangan po na i-monitor yung mga special causes. Kasi po yung mga process operator po is kumukuha ng data at plot para ma-control at ma-track yung mga regular intervals. Dito po ino-obserbahang mabuti yung control limit kung ano po yung magiging pattern ng process average at process in control. Step 13. Determine process capability. Bago po tayo magpatuloy sa next step, kinakailangan po na i-determine muna natin if yung process po ba na ginamit natin is capable dun sa ina-expect natin mangyari. Kasi po mahirap po na yung process na ginamit natin is capable pero hindi pa rin po capable para ma-meet yung customer specification. Kaya po pag ganito po yung nangyari, it's up to the management po kung papalitan po nila or mag-upgrade sila ng capability kung saan kinakailangan pong bumili ng mga bagong equipment. Next po is Step 14, Respond to Trend and Outlimit Data. Ito po ay isa sa pinaka-importanteng function ng SPC dahil kinakailangan pong ipagbigay alam agad sa mga operators kung may problema o dapat i-improve sa isang product para pong maiwasan yung mga defective product na pwede pong mag-result ng scrapped or rework items. Kaya yung pinakamainam na way po para sa pag-respond sa mga ganitong cases is hanapin at i-identify po agad kung asan yung problema at dito din po na-apply yung team participation. Step 15, Track SPC Data. So, dapat pong bigyang pansin yung pag-track ng SPC data. Dahil yung paggawa po nito ay magbibigay sa kanila ng accurate production capability, quality of their processes, tapos malalaman po nila yung mga trends na pwede pong ma-develop at kung saan sila dapat mag-concentrate para sa improvement. Step 16, eliminate the root causes of any new special causes of variation. Ito po yung about sa pagtatanggal ng core issue na nagdudulot ng mga problema. Kasi po minsan po pwede pong magkaroon ng mga special causes gaya ng machine faults, power surges, operators absences, at computers fault. Kasi po kahit po yung process na ginawa natin is under control na, pwede ulit magkaroon ng special causes of variation dahil malalaman po ng mga operators na yung SPC data is may possibility pa na tumaas or bumaba sa control chart data. Kaya po yung pinagmumulan ng mga core issue is dapat ma-prevent or matanggal agad para po maiwasang lumala. And lastly po is Step 17. Narrow the limits for continual improvement. Ngayon po na under control na yung process at na-eliminate na yung special causes, time na po para accomplish yung mga improvements. Kung saan yung process average po is dapat nasa center ng specification average. Kasi po pag hindi po ganito yung case, kinakailangan pong i-limit yung mga improvements. Kasi po yung pag-center po ng process sa specification average at narrowing the limit, yung magre-resulta po ng konting problema at pagbit ng mga specification na nais nila sa isang product. Scrap page will reduce, the process will become more robust, quality will improve, and cost will decrease. The key, of course, is finding ways to improve the process, but with SPC, one has the understanding of the process necessarily to see and comprehend the problems. Only then can real improvement follow.